Hello student, how are you? This topic is about speed and I have created this lesson plan from the Cambridge Indoors syllabus, that is the latest syllabus, and we are covering the following points in our today's lesson. Okay, so in our lesson plan. So let's come towards the speed. But before understanding the speed, we should understand the distance first. Okay, what is the distance covered, because it has a direct link with the speed. So what's the distance? For example, if a body moves from one point to another point, from A point to the B point, so it is possible that the body adopts some different paths. The curved path might be a straight path. So these are the following paths. So these are the different paths covering from the A to B. It includes the curved as well as the straight, but not the directly from the A to B. Okay, so the length of this path covered is called distance, and it will always give you just a number along with its unit. Okay, so along its unit, so it will be just a number. It means it is a scalar quantity. That is a distance. So what's the distance? Distance is that how much length you have covered while following this path. Okay, and here is the definition of the distance. Length of the path covered is called distance, and it will never be equal to 0 if a body has changed its position, as in the diagram below. Okay, but there is another quantity, very important quantity, might be if a body is going in a straight line, in a straight direction. Okay, as shown in this diagram. Okay, we can clearly see in the diagram that I have drawn a straight vector. A straight vector is starting from the initial point A and going straight to the B. This special vector is called, this is the displacement. Okay, so this is the displacement. So what's the displacement? Displacement is the least distance covered, and which is surely certainly in a straight line. Okay, so that is called displacement. So displacement must have some direction, and it's if we draw with the help of a vector, then its tail will always be on a initial point and its head will be on a final point. So let's take another example in which I will show you the difference between the distance and the displacement. So for example, if I have drawn this north, south, east and west. Okay, this is the north, this is south, this is east, and this is west. So let's take an example of a moving body that is moving towards east and then north and then towards west through some units, through some kilometers, as shown in the diagram. Okay, in this diagram, a body is first moving towards east, and how many units? Let's say it is the 2 unit, and 2 unit might be it is 2 kilometer, and then it is moving 3 kilometer or 3 unit towards north. So what is the total distance covered? And we express the distance by the s, and that is 2 plus 3, that is equal to 5 units. Okay, but what is the displacement? Displacement, as I have told you, that it is the straight distance from the initial point to the final point. So it must be represented by this vector, and it is clearly a right angle triangle, and we can calculate this displacement by Pythagoras theorem. And what is that? If I want to calculate this displacement, let's apply the Pythagoras theorem. So it will be 2 square plus 3 square, that is equal to 4 plus 9, and that is the square root of 13. So square root of 13 units is the displacement covered from the initial to the final point, and it will be the less than 5 units. Now let's gradually understand the speed, because once we have built our base knowledge of the distance and the displacement, distance is just a numerical value with a unit. Displacement is a numerical value, I mean distance, but it has also its direction, that's from the initial to the final point. Okay, now let's understand the speed. Okay, so if we will understand speed with the help of an example. Okay, first of all, if the two bodies or more than two bodies, when we, in our everyday life, when we observe the motion of the bodies, we always compare their distance covered with the time taken. Okay, so let's take an example in which the two cars are moving, and let's compute their speed. Okay, so in this example we can see the two cars. Let's say the car A and the car B. There are two cars which are traveling from the same point. As the initial time is 0, it has started, but we have seen that, for example, if I say they have covered the same distance, if their covered distance is, for example, 100 meters, and if I assume that the car A just take 10 seconds to cover this distance, whereas the car B takes 12 seconds. So we can clearly see that the car B is taking longer time and as comparable to car A. So it means when we will compare their motion, when we will compare their distance that is same with the time taken, then we can easily differentiate that which car is moving at a high speed and which car is moving at a slow speed. So on this basis, the speed is basically the comparison of the distance covered by the moving body with the time taken. So that's why we make a definition that the speed is the distance covered divided by time taken per unit time is called speed. So here's the definition of speed. So this is the speed. As we can clearly see that this is the distance covered per unit time. So there are different bodies, macro bodies like ourselves. We move at a slow speed, but if we compare our speed with the speed of the light or with the speed of an electron, that is 2 × 10⁶ meter per second in the first orbit of hydrogen atom, that is so much high than our speed. So those are the high speed moving objects. Okay, so the speed, that's why we write the speed is equal to the s/t. And from here we can get an important formula, that is S is equal to Vt. That is an important equation we apply in the problems. Okay, but here I want to tell you, I want to differentiate between speed and another quantity, that is the vector quantity, that is the velocity. And velocity is, you can say it is a speed, but in a certain direction, because we cannot always define the motion by just a number with its unit, but we sometime in some scenarios, in some circumstances, we need to tell the other person that in which direction the body is moving. So here I'm going to give you some examples. Just let's take this example that I was already discussing. In this example, this car is moving in this direction towards positive x-axis, or we can say towards east. Okay, so velocity will be, if we measure the speed, then the speed will be measured 100 meter divided by 10 second, that is equal to 10 meter per second. Okay, but if we say what is the velocity, then the velocity is equal to 100 meter divided by 10 second. And what's the direction? Towards right. I must write it towards right. Okay, in your higher classes you will learn about the unit vectors as well. So this is the 10 meter per second for the car A towards right. So this is the velocity towards right. So this is a ball. Its initial velocity is equal to 0, but we see that it will fall down because of the gravity, and when it is falling down, it is basically covering the path. And this is the path. This ball will come down like this, and as it is falling down, we know its velocity will increase, so it will cover more distance in every interval. So just before striking the ground, its speed will be, the final speed will be the maximum. In our higher grade we will understand the formula to compute this value. So what's the direction? Direction of its velocity is this, but at any moment we can calculate the speed by simply distance covered divided by time taken. Okay, so this is the example. In another example, So in this example, this is a football that has been kicked by a footballer, and it will adopt this path, and it will make this projectile motion. So during this its motion, it will follow this trajectory, it will follow this path. So at any moment, if we want to calculate its velocity, then it will be the velocity, this will be the direction of velocity at this point, this will be the direction of velocity at this point, and it is along the tangent. But the speed doesn't require any direction, so speed is simply distance covered divided by time taken. So we have discussed that in detail the difference between the velocity and speed. So we have covered these following points. Okay, so speed is a scalar quantity which has just a number, its magnitude along its unit, but velocity is a vector quantity. Now let's discuss the average speed. So let's come back to this example when we were discussing these two cars. So the average speed, what's the, by the way, the average speed? This is the average speed, 10 meter per second, that is. And how did I compute this value? This is the total distance covered, total distance covered. So average speed doesn't tell you the speed of a body at some instant of a time. It tells you, it gives you the whole picture of a journey, whole picture of a motion. It gives you that what was the average value of speed, might be the speed of a body will increase, will be increasing or decreasing during the motion because of some obstacle, because some hindrance, okay, because of a curved path, a sharp edge, okay. So that's why we define the average value, and that is the total distance divided by time taken. But what will be the exactly at this point, what will be the speed? This is the instantaneous speed. Okay, this is the instantaneous speed. So here is a simple difference between the average and instantaneous value. So here is the simple difference between average speed and instantaneous speed. We compute the average speed by dividing the total distance and the time taken. And moreover, in more detail, I will make a special video about the graphs, in which we will learn that how do we calculate average speed from the graph. Okay, yes, we can calculate it from the gradient. So basically the instantaneous speed is the specific value of speed at a special interval of the time. How do we measure the speed from the graph? Well, it is specially a separate topic, and we will cover it later, but in a short way. For example, if we draw the graph between the two quantities, the distance covered on the y-axis and the time taken on the x-axis, and if a body is moving with a uniform velocity, then it will have this graph, if a body is moving with uniform velocity. And how do we know that the body is moving with uniform velocity? We can calculate the gradient of this graph, and for that purpose we need the 2 points, and this is the run and this is the rise. This is the change in the y quantity, that is the change in the displacement distance, and this is a change in the x quantity, the quantity taken on x-axis, that is a delta t. If we divide these two values, then we can calculate the speed. So what is the speed? So speed is the gradient, as well as we say it gradient or slope. So gradient of distance time graph. So this is the speed. But if I make the same graph, but now I take the displacement on the y-axis, then the gradient of the displacement time graph is equal to velocity. So what we can see, this is the displacement time graph, and it is a straight line, and that is representing that the body is actually moving with uniform velocity. Now I will not say uniform speed, uniform velocity, because I have drawn the graph of a displacement versus time, and for this graph we can say uniform speed. Okay, so this is just a reflection. I will cover this topic on the graphs in my another video. Okay, so this is all about speed, and we measure the speed through the speedometer. It is a very accurate and precise device, and the SI unit of the speed is meter per second but there are other unit as well, like kilometer per hour, and as well as we can say kilometer per second, mile per hour. Okay, so these are all the units of speed, but the SI unit is meter per second. So stay tuned with me for the other videos. Thanks to and thank you so much to watch this video.